The next rule we're going to talk about is how to take derivatives of exponential functions. So here I've got the most general form, f of x equals b to the x. So you want to think about this as, say, 2 to the x, 3 to the x, e to the x, something like this, right? Some kind of exponential function. So b is just the base. So just to be general, we'll start with this b to the x. Now, I do want to make it very clear, this is different than the power rule, right? If I've got the power rule, I've got x to the n. X is the variable, n is just a number. Here it's opposite, right? The variable is in the top. These are exponential functions. And you're like, why is she talking about this? Everybody knows this, right? But then it's easy to mess it up because the rules are different depending on where the x is. So you get used to doing nx to the n minus 1, and then you start doing that with these when the rule is different. So just be aware. So now let's look at what this is going to look like. Let's just take this general form and see if we put it into the form of the derivative, what are we going to get? So remember, I'm doing the usual thing. F of x plus h minus f of x over h. Of course, here my f of x is this b to the x. So we can clean this up a little bit here. Both of these have a b to the x in them, right? Because this is b to the x times b to the h. So that this becomes b to the h minus 1 over h. And here I can do something that I did before with a constant. The b and the x have nothing to do with the limit because the limit is just over h. So I can pull that whole thing out. So I have b to the x, and then I have this limit. Well, I don't know how to do that limit very well, right? It's 0 over 0, but what's b? I don't know what b is. I don't know how to get that limit quite yet. We'll get to that, but right now, we're not going to do the limit. We're just going to look at it a little bit carefully. Because if you look at that limit and you look at this, you will notice that it's very similar, right? So remember what we did. We did at one point did something like f prime of 0. We were using the definition of the derivative to calculate the derivative at the point 0, right? So this would be f of 0 plus h minus f of 0 over h. Limit, I forgot to write the limit. I'll squash that in. So in the case of this guy, in the case of the exponential, if that's basically what I have here, is b to the h minus b to the 0, which is 1 over h. Okay, which happens to be what I got here. So without explicitly calculating that limit, what we'll do is we'll notice that that means that the derivative is f prime of 0 times the function itself, right? Because this is just this guy. This is a number, okay? So, in other words, for an exponential, the derivative is proportional to the function itself. It's the same function. The b to the x is the same. The only difference is that I've got some number here that I'm multiplying it by. That number, whatever it is going to depend on the base b. We'll learn later what it is. But for the purposes right now, we're just going to notice that that's what we've said. So the rate of change of any exponential function is proportional to the function itself. When you take the derivative of the exponential, you basically get the exponential back multiplied by something. Okay? So, so you're like, okay, well, what does that help me? Well, if you remember what we talked about way back, before I go there, let me just rewrite this up here, and then we'll have this space. So this is f prime of 0, b of x. Right? If you remember way back what we talked about in chapter 1 when we talked about exponential functions, I said, oh, there are various different ways to define what the natural base E is. And one of them is by letting E be the number that makes this limit 1. Okay, it's a little weird. You can define E in like maybe 3 different ways. They're all equivalent ways, like they all end up being the same thing. But your book likes this way, and this is why they like it, because it makes the derivatives sensible. You don't have to worry about the value of that limit. So let E be defined to be the number that makes this thing the limit as h goes to 0 of e to the h minus 1 over h. It's going to make that limit equal to 1. So, in other words, if you do this, as long as you're dealing with e to the x rather than 2 or 4, you don't have to worry about evaluating that limit. You can just go ahead and use this, because by our definition of e, then we can say this limit is 1. So the derivative of e to the x is just e to the x. It's the same. No matter how many times you take the derivative, you're still going to get e to the x back every time. It's the only function that does that. So it's really kind of cool, right? It's very nice, easy to take the derivative of e to the x. It's just e to the x. Okay? So with that in mind, let me just briefly put that up here, and we'll worry about functions of the b at some other time. So the derivative of e to the x is e to the x, and the derivative of x to the n is nx to the n minus 1. So basically those are the two rules that we have, plus the constant multiple rule and the sums and differences. Well, I can write them all, right? So I can write the derivative of CF is C df dx, and the derivative of f plus or minus g is df dx plus or minus dg dx. So those are all the rules from chapter 3.1. So let's use them. I'll do one quick example with e to the x, and then maybe I'll have another video with a few more examples so that this one doesn't get too long. Okay, so here's just some function. The square root of x minus 2 e to the x. And I'm asked to find the first derivative and the second derivative. So it's, once we have the rules, it's not hard, right? I want to write this as x to the 1/2 minus 2 e to the x. So this is my f of x. Just rewriting it with the power rather than the square root. And then I go ahead and evaluate with these rules. The first piece is just the power rule. So I'm going to have 1/2 x to the negative 1/2. And then the second piece is minus 2 times the derivative of e to the x, but the derivative of e to the x is just e to the x. So this doesn't change. It's just the same thing. Now, second derivative. I mentioned that before. Oh, I told you what second, third derivatives were, but we didn't do them when we had to do it with the power rule. Now we can do it here pretty fast. We just now take this and we take the derivative again. So power rule, but now I've got a coefficient in front, so fine, I just leave it there. And now I do nx to the n minus 1 on what, ooh, it didn't help, like this, right? There you go. On the x to the minus 1/2, right? So this would be minus 1/2 x to the minus 1/2 minus 1, right? And this one just stays the same because the derivative of e to the x is e to the x. I could clean this up a little bit. Sure, there it is.